All right, we're going to jump into the hardware section of the ultrasound machine. In this part of the presentation, which is likely what you're very interested in, is really the general disassembly of the entire system, part identification on what you're looking at, what those parts functions are, and we've done our best to collect some of the most common failures of those parts, and you're going to find that a lot of these parts don't fail all that often. There's going to be more patterns of failures with certain items than others. And in general, the machines run really well. They do fail. And with technology and the form factors shrinking, you're going to see if you worked on previous machines like the Philips IUIE, the HD series, even some more legacy machines from the other manufacturers, there's just a general consolidation of electronics to have single PCBs and single sections of circuitry do more simply because the hardware is now faster. An example is just more densely packed switches on BGAs and ICs. Just because there's more, it can process faster and more. Some really cool multiplexing technology to where taking one channel and turning it into many, but really using only one circuit because it's so fast. And also just computing power. Computers have not stopped evolving in its processing power, and in these newer machines, really taking advantage of those faster CPUs, faster bus speeds, faster RAM speeds, faster memory speeds. All of these things combined, you can do a lot more with less, but at the end of the day, it generates more heat. And heat is really what will deteriorate and ultimately possibly cause these electronics to fail. So we highly recommend keeping these on a regular PM schedule per your program you have at your facility, but keeping all of the fans clean of dust, the filters clean of dust, looking at the processor fan, if there's a video card fan, make sure that when you're doing a PM, get all the dust out of there so it doesn't collect up in the bearings and whatnot. And because when those stop running, no airflow, machine really starts to bake over time, and that could be preventing some of the failures if those things are kind of maintained and kept clean. So we're going to jump into it on the different subsystems. So generally in ultrasound, we think of ultrasound systems in really 5 distinct categories. There could be some parts as they continue to consolidate functions onto PCBs that, in legacy machines, they may have been separated. Now they're starting to combine them together. There's some gray area here, but in general, all machines have a front end, which regulates power of the ultrasound machine to the probes. So this is the part of the subsystem that really takes the transducer and gives it power to emit sound from the crystal, and then if that crystal returns information, then it will take that information, digitize it, and give it to the computer. In this particular case, the front of the machine here, we'll talk about the acquisition module here, but the front section here is really the front end. It's in the front here, just to be quite clear. Traditionally, it is there. Some machines it's not, but it's really where the connectors are of the system to the transducer, and then the associated beamforming boards that, in this particular case, is married to that transducer select functionality. Now, the back end is typically, you might have heard back end processor, processing unit, but this is going to be in the back of the machine behind the front end. So in this particular case, quite literally, it is the back end. It is the computer in this particular case. It has all the processing power. It has a few very specialized boards that will ingest all this information of sound and then compile it into an image. So in the computer, you're going to have your processor, your RAM, it needs power. Your network connectivity is going to be sourced from your computer. Your video card, which is really important because that does a ton of processing power and putting those images together for the user. But all these things that are in a computer, like hard drives for data storage, that all occurs in the back end. So if you actually have raw send and receive of sound being the front end, where does all that information go? It goes to the back end to get processed, then to get pushed to other devices that we're going to talk about here in a minute. Power supply here. Power supply is going to be on the bottom of this machine in the back. We'll talk about that in a minute. But this has a power supply. It's called a power module. It's in the back, and it just supplies general power to the entire machine. Pretty self-explanatory. The chassis is, again, pretty straightforward. The chassis would be anything that's really architecturally a part of the machine that's really mechanical. So, we have an articulation arm here that holds up your monitor. You have the arm here that is a control panel articulation arm. You have your fans and your filter, which are also underneath here. We'll show you where that is. But and then you have things like casters that are a part of the chassis, and then just the metal frame, right? The metal frame, which we really don't see fail, but just kind of the chassis mechanical attributes of the ultrasound system would be really grouped into that chassis category. And then we have external interfaces, and these are all the things that the user would use to interface with the ultrasound system and the probes. And in this particular case, we have the monitor because that displays information to the user. You have your touch panel here, which is an interface where the user can touch that to input data and to input commands. Your control panel is here with your trackpad, your kidney buttons, that your mouse functions, all the necessary buttons and knobs, potentiometers, slide pots, which we get LGC, TGC, all of these functions that a sonographer would use to manipulate and control what they want the machine and the probe to do to give them an appropriate image. So before we get into the disassembly of the machine, what tools do you need to be able to get into it? So what we found is, a torque set, that is the most common screw type you're going to find holding this machine together. A standard Phillips screwdriver. There's a couple of Phillips screws on this machine where you'll need that. Standard flathead screwdriver, that's more for some prying some things open. There's a lot of kind of rubber grommet compression type of connectors that's holding a lot of these body pieces together. And a really basic wrench set or some adjustable pliers. Specifically, there's some connectors that kind of go through a plastic, and on the other side it's threaded, and there's just a kind of a nut there. Nothing heavy duty, just something that you can kind of grip onto that nut, undo it off the connector so you can remove the plastic from it to get to what you need to get to. And finally is Summit Imaging's technical support. We have a reputation of providing free 24/7 technical support to the HTM community. We just want to help. We know the equipment's down. We know that if the equipment's up, it increases patient access. It increases the efficiency and capacity of all the healthcare that's being provided out there around ultrasound. And we want to help you compress that system downtime. And in reality, we are here in your back pocket to assist you through any troubleshooting process. The console, the system here, parts diagnosis, probe failures, we are at the ready to help you absolutely free of charge. And so, after training is finished, please don't hesitate. When a machine fails in the future, it could be tomorrow, it could be 3 months from now. You might just need a refresher on what you need to do or how to diagnose something, and that's where our technical support really shines. So, please take down this information. It's readily available everywhere on our website, and we are here to help you absolutely for free of charge anytime you need us. Email, phone, text, whatever you prefer, we are here for you. All right, we're going to take a look at the front end now and show you the parts and how to deinstall them. Again, reverse the deinstall process to install. Really straightforward, but we're going to be specifically talking about the acquisition module and the acquisition control board. The acquisition control board is technically a front end item, but it is inside the Ebox, so just bear with kind of the system architecture here. There's that gray area. It's physically inside the Ebox, which is technically a back-end item, but its functions are really beamforming and controlling the acquisition module, which technically makes it a front-end board. We're going to start off with the acquisition module. This is the most common failing part in the machine, as we talked about before. The most common faults here, CW noise and color noise, like we talked about. You'll get some hard error code faults, 514, 005. Also included is our broken transducer ports, which do happen, or probes not engaging or probes not recognized because there's something faulty in the probe identification circuits that are on there. So what we're going to do here is we're going to remove the power module because we are going to get access to the entire Ebox and acquisition module assembly. Note, there are some quicker ways of doing this, but we're going to show you the safest way to get the equipment out to prevent damage from occurring. So we're going to actually remove the entire Ebox and acquisition module assembly and then remove the acquisition module from there. So we're just kind of taking you through the process of disassembly here as if you are brand new and really trying to prevent any accidental damage along the way. Power regulator boards coming out. Those three connectors we just removed were fan speed connectors, or fan power connectors, I should say. This is the ACB, and the connectors I was just connecting to up front is the acquisition module itself. So removing these so the acquisition module can dismount from the front, otherwise it's connected to these boards. This is our fan filter, good to know for a PM. Snapping off the side panel, these are just kind of on rubber grommet type of clips. Top plastic just clips on and off, same way. Same thing on the other side, just pull off the panel. And we're going to remove this next plastic top panel here. We're going to go get the front panel, this front plastic cover. We have 4 screws. You can see the transducer ports there. If you look at those closely, you oftentimes, if you're having some issues on getting good connections in one port versus another, look at the port that's faulty and you might be able to see some broken connections in there on the interconnect. And we're going to remove this front plastic piece to get access to the metal assembly behind it, which will contain your acquisition module. So your acquisition module is that front piece that is attached to the Ebox, but just for being thorough in this training, we're going to go ahead and remove all the connectors, take pictures of your connectors and cables and where they go before you start removing them, so you know exactly where they go back. Referencing an external source of where your cables go is absolutely possible. We find that actually ends up taking more time than just pulling out your cell phone and taking a couple of pics on where everything should go. Even better, taking a video and kind of strafing up and down to see, for something for you to reference on exactly where the cable should go back to when you reassemble the machine. As you can see, everything connects to the Ebox. It is the central processing unit of all the information on the machine. And it also outputs everything that the user uses. So now that we have the cables, we're getting them out of the way, we're going to remove all the screws to the perimeter of this metal chassis. And what's going to happen is that we're going to tilt this assembly forward. That's going to be your Ebox and your acquisition module. You're going to see this process a few times in this training. We're kind of moving at real-time speed here, and we just wanted you to see it a few times so you're comfortable with the process. And there's that right latch that will prevent the whole Ebox and acquisition module assembly from tilting forward. It's going to tilt forward with all the screws removed. That's what's going to hold it up, so there's no accidental tilting and kind of unnecessary impact to the assembly. So now that we have all the screws being removed, we're going to pull out to the right on that tab and let it fall forward. As you can see, with all the cables removed and the power module in the back allows that to fall forward. If you don't go through that process, if you keep trying to tilt the machine, the assembly, it will start tugging on the cables and start breaking things. All right, get a good grip on it. It's not light, not heavy, and now you have this assembly removed. Now we have your EKG extender. That does go bad, not very often, but it's something to look out for. It's just really a small electronic device. It's really a pass-through through EKG to get to the computer there. Now we're going to remove these perimeter screws. And this is what's holding the acquisition module to the Ebox. So going around the perimeter. Again, you're going to see this process a couple of times to get access to the parts. We didn't want to show you this process just one time. We really wanted to really set in for you to watch it a couple of times because we are moving in real time here. Now we're going to slide the acquisition module off. If that ACB and power regulator was still connected, that would be an issue for us. It wouldn't come off very easy and cause some damage. And that is our acquisition module, and reverse the steps to install it. And that's it. All right, we're going to jump into an acquisition control board. This board is one of the boards that directly connects to the acquisition module. It is a fairly common failing board. Some common faults we've seen are 511, 503, and some broken connectors here and there. But it is the board that's next to the power regulator board inside the Ebox. And we are going to show you that it's the left card out of the two. So we had already removed the power regulator. Now we're going for the ACB. And this is really, the function of this board is really controlling the acquisition module. It's also the main beamformer. It takes all the information from your acquisition module that it sent and received to the probe, and now it's ingesting it and pushing it to the processing unit, which is the computer here, or the Ebox. We're now going to look at the back end. The back end of today's systems are much more modular than they were before, just with the speed of the PCs nowadays that are running these machines. But at the back end on this specific machine on the Epiqs is really just the Ebox, which is just a fancy term for it. It's the computer that takes all the information to create an image, does all the processing, is all the interfaces, and really the brains of the operation here. So we're going to jump into how to work on an Ebox. This is disassembly to get to the Ebox. This doesn't fail too often, but it is the heart and soul of this machine. In addition to the acquisition module, really it's computer. We're making sure all power is removed from the machine. Should be standard operating procedure when you work on any equipment. And to get to the Ebox, we must first remove the power module. So we have 2 screws again. We're going to slide the power module out. The reason why we're removing the power module is because at the bottom of the power module, you saw that connector? That actually plugs into the bottom of the Ebox, so you can't get it out if that's still connected. Getting access to the back cage. So now we've exposed the Ebox, and you see all those connectors on the bottom. That really connects to the power supply that we were just talking about. And we have to remove these 2 cards. We're going to start with the power regulator board. Those are connectors down below for your fans of your system. And those fans obviously go down, pulling air from the bottom. That's our power regulator board coming out. And those connectors that we were just pointing at goes to your acquisition module on the other side of that Ebox. So now here's our ACB. Also plugs into the acquisition module on the other side. This is your fan filter. So during your PM, go ahead and remove this. Make sure it's clean. We want as much fresh air getting into that internal of the system as we can. Side piece pulls off. It's just held on by those rubber clips. We're going to pull off and snap off the top white cover of the Ebox assembly. And we're going to do the same to the other side. The other side pops off. Unclip the top plastic is next. Now we have to remove the front. And so now we're going to get to the plastics and remove this front plastic. So common faults of the Ebox are going to be your blue screen of death, constant rebooting, disk boot errors, a lot of runtime errors. System can't boot into imaging, so kind of premature fault before it gets in the imaging screen. ECG goes through it, so EKG failure or noise. Network failures, obviously display failures, touch panel failures, kind of all over the board because that's a central processing unit for everything. So now we're going to go disconnect all the connectors. Highly recommend you take a picture of these connectors and connections prior to removing them so you have a reference to put them back. Pretty standard, but we find that it's easy just to go back to exactly what you have because some machines may have some connections that others don't. In this particular case, everything's pretty standard, but when you have your own picture to reference, you know exactly where these cables should go without any guessing. So you can see everything is connected to the Ebox. And we're getting to fan speed connectors here. USBs, make sure that you mark which one goes where because it does sometimes bark at you if the USBs are in the wrong spot. And you can see above our hand here that, there are some indicators of what cables go to what and what they are, some color coding, but it's definitely not complete to the rest of the cables that we kind of removed here shortly before. All right, let's get those cables out of the way. Now we're going to actually unscrew the chassis of the Ebox and acquisition module from the chassis of the ultrasound machine. So this is a big assembly going to come out. And it's going to tilt out. This is kind of something that's really good to note and to expect is that it will tilt out once we undo all these screws. And that latch right there is important to note. That's going to hold in the assembly from tilting forward accidentally when all the screws are removed. So now that all those screws are now removed, we're going to pull out on that latch, and then it'll tilt forward. And now we can just slide it out like a big cartridge. Get a good grip of it. It will slide up. And that is your Ebox assembly with a fan assembly down below.